So this is my design for a 3D printed visor. It focuses on low print time and using as little plastic as possible. The design is printed as a continuous loop. I'm currently using a 0.8 nozzle, which means that it only uses, it only prints a single loop, 2 lines in the width. The width I'm printing is 1.4. With a 0.4 nozzle, that's 4 lines instead. The layer height is 0.3. So the design is folded out. You see these 2 lines are parallel. And this one, and let's see if we can have it go, and that one, these 2 make a lock. One slides into the other. Designing it this way means that you can stack them quite efficiently. On this printer I can get 6 or maybe 7, but by tweaking the radius it's printed in, I think I can get 12 onto this build plate alone. Since it's a flat geometry, it can also be printed in height. So optimizing this design would allow you to print several hundreds in the height if you had the appropriate printer for it. This could also be extruded plastic, which was then cut in some kind of fashion and produced in millions. On the outside you have these small tabs. That's where you hook in the plastic sheet. You start with hooking in the 2 first topmost ones here, and then you hook on the 2 sides. Since you print this in this fashion, you could actually bend the entire design to hook on to the hooks and then bend it backwards. The end, these 2 holes, that's where you put the rubber band. You need 2 of them to retain the rubber band completely. The height is 5 millimeters. That means that the tabs that stick out on the sides, they fill in the 6 millimeter holes in the standard. The European standard is 80 millimeters in between the holes, and the holes are 5.5 to 6.5 millimeters in size. By being 5, they should be able to slip into either or. I'm currently printing at 100 millimeters a second. You could go down to 0.4 nozzle. You get a lot finer detail that, and especially the lock. The lock is a lot more secure when you print using finer detail. The print time right now for this configuration is 8 minutes. That's for a single one. That does include some travel and stuff, so the print time for each one could be cut down to maybe, I don't know, 6 or 7 minutes. If you print this at more normal controlled speeds, I would say about 15 to 18 minutes per each. So I will assemble this one for you so you can show how that works when it's done. For anybody who is wondering, the build plate where I'm printing on top, that's a glass plate. I've covered it with school glue. This, let me see here. It's like a stick of glue that you just go over it. I touch it up with some water on a sponge. just to wet it again, and it refreshes it. It lasts for a long time that way. I'm unsure if you need it. You might not need it. I see a lot of people are printing single visors and then pushing them out using the print head. That's also an option, but maybe not as secure due to this kind of design. I don't know. It might be possible if you print it the other way and then push it out the other way instead. Maybe you design in some kind of pushing tool, a small circle or something. I don't know. So now it just started printing the brim. It's a raised element that is maybe unnecessary. You could have some kind of slip-on textile or something and slip it onto the inner loop instead of having to glue something directly onto it. That's a possibility with this design. The height, like I said, of the main construction is 5 millimeters. The height of the brim adds an additional 7, so you can have some foam attached. The foam is 10 millimeters in width and approximately 12 centimeters long. The entire construction is very lightweight, which means that it should be comfortable to wear for a long time. The rubber band I'm using is 140 millimeters long. I think that's a bit on the short side. I would recommend 16 or maybe even 18 millimeters long. But then again, I have a pretty big head. I'm printing in PLA. I hope my design can help in some way. A lot of the other designs are better suited for reusability. They're a lot more steady. They will not bend or break over time. My design is a lot simpler, and so it might have some problems like that. So at this point, I usually take a tool of some kind and just knock it loose. There we go. Before I start handling it completely, it usually pays off to, let's see if I can get my cell phone. I removed some of the stuff, but it looks pretty okay. I'm gonna let it cool a little bit before I start handling it. So I have a plastic sheet here. I've beveled the corners a little bit, so it's a lot more comfortable to use. Then I start with hooking in the front portion, like this. There we go, that's on. And then I hook on the sides. That's on. And that's on. Now the sheet is installed. I can do the lock next. I use this grip and I slide it in. There we go. As you can see, it's a bit deformed. Depends on the print quality that you use. If you print using a 0.4 nozzle, then it's a lot better. But as you can see, you can straighten it out. To make it symmetrical, you have to bend this leg out a little bit, like that. Now it's symmetrical. Of course, you might want this top side to point downwards instead. Now we can install the foam. It's very simple. Simple piece of foam, that is. Let's see. Wow. Might want to center this a bit better. There we go. That's installed. Now, for the rubber band, you slip it in, flip it around, slip that in. There we go. The other side. It's a bit hard with the camera. There we go. And then the other side. There we have it. The finished visor. Thank you.